Arrays and pointers are closely knit together. So in this lecture, we will study about the relationship between arrays and pointers. Right? There are two widely used formats to represent a block of data. Block of data means a group of data. Okay. So this group of data can be represented by two methods, by a pointer or by an array. For example, char star CPTR. What is this? You have already seen such type of statements. So here star means we are creating a pointer. The name of the pointer is CPTR. So the variable name is CPTR and this variable is a pointer to a character. Okay. So this is a pointer to a character. So it will store the address of a character. And the second is, what are we doing here? We are creating an array whose name is BUF, whose size is 80, and what is the data type? Char. It means it will store characters, right? But I am saying that we can use this method to represent a block of data also. You already know that we are creating an array of characters here. So this is okay because we are already representing a block of data because we are creating an array here. But what is this? This is a pointer to a character. How can we represent a block of data using a pointer to a character? This is how we can represent a block of data using a pointer to a character. The name of the array is a constant pointer to the first element of the array. In the previous lecture also I told you that when you just write the name of the array, it means that this is an address. Address of what? Address of the first element of the array. Okay. So what is an array? Array is actually a pointer. And what are we doing here? We are explicitly creating a pointer. So both of them are same. That is why both of them can be used to represent a block of data. So what are we saying here? The name of the array is a constant pointer to the first element of the array. You know that the name of the array is pointed to the first element of the array. But what is constant pointer? Constant pointer means when you create char buff 80, you are creating a pointer whose name is buff and it is pointing to a block of data whose data type is character. But this is a constant pointer, means later in the program you cannot change it to point to anything else. No, this is not allowed. But this char star CPTR, this is not constant. You can change it. CPTR is originally pointing to this block of data, suppose. So this is same. But afterwards, later in this program, you can change it to point to something else. The only difference is this, right? So the name of the character array is equal to const char star. So it means that when you write char buff 80, it also means that you are creating a constant pointer to a character whose name is buff. These are both the same things, right? You cannot assign another address to an array name. I have already told you that initially buffer is pointing to some block of data, but afterwards you are changing it. This is not allowed. Okay. So buff cannot be changed to something else. You cannot do this. Buff is pointing to CPTR. No. And a pointer such as char star CPTR, it can point to anywhere. Initially it is equal to buff, then it can be equal to something else. Okay. And an array such as char buff 80, however, points to a block of memory allocated by the compiler. It will always point to that block of memory which is storing 80 characters, right? An array name without an index is an pointer to the first element in the array. We have already known this. Okay. Here is another example for this. Here what are we doing? We are creating a character array of size 10. It means what will happen? The compiler will allocate memory for 10 characters. Okay, and these 10 characters will have some base address. So the first character will be at 1000, next character will be at 1001 because the character occupies 1 byte. Okay, so next will be at 1002 and so on. Okay, and what is P here? P is a pointer which is storing the address of the first element, that is 1000. So P is pointing to this. Okay, so this actually happens when you create an array, right? And the following statements are identical. P and ampersand P0. What is P? P is the base address of the array, that is 1000. And what is ampersand P0? P0 means the element at array index 0. So what is the element here? Suppose A is here. Okay, and before that element we have put ampersand. What does ampersand means? Ampersand means address. Okay, so this expression means address of P0 means address of the first element of the array P. Okay, and what is this? This is also the address of the first element of array P. Okay, put another way, P is equal to ampersand P0. Both are same. And this expression, when you try to evaluate it, it evaluates to true because the address of the first element of the array is same as the address of the array, right? An array name without an index generates a pointer. Conversely, a pointer can be indexed as if it was declared to be an array. Pointer can also be used like an array. How? Here what are we doing? We are creating a pointer. So it is intended to store an address and its name is P. And in the next line what are we doing? We are creating an array of 10 integers. Okay, and the name of this array is I. So I, what is I? I is actually a pointer which stores the address of the first element. Suppose the address of the first element of this array is 2000, so I will store 2000. Okay, and then P equal to I. So I is storing an address. We can assign this value of I to P also because P is also a pointer, so it is also able to store an address. So both of them are containing the address 2000. It means both of them are pointing to the first element of this block of memory, right? Then P5 equal to 100. Okay, so here what are we doing? We are using this pointer just like an array. So pointer can be indexed as if it was declared to be an array. So we can change the fifth element. Suppose this is fifth element using P also. Okay, so P5 is equal to 100. So how is it possible? So what do we mean by P5? P5 means p plus 5 and then star. So it means this. Now what is this? This means P is an address, that is 2000 plus 5 means we are adding 5. So it will jump 5 elements forward. So here, because elements are integers and suppose each integer is occupying 2 bytes, so it will jump 2000 plus 5 into 2, 10 bytes. Okay, so it will move to 2010, and star means the value at that place. So we are changing that value to 100, right? So this we can see here, star, it means star p plus 5. So p is the base address, that is 2000 plus 5 elements, okay. So it will jump 5 elements next. Actually, how many bytes will it jump? Suppose integer is storing 2 bytes, it will jump 10 bytes. And then star means the value at that location will be changed to 100. Right? Now we have a question. If you point a pointer to the middle of an array, what will happen? Answer is, the pointer can be used as the name of a new array whose first element is the element to which the pointer is pointing to. Now let us understand it with the help of an example. So here is an example. Here we are creating an array of 10 elements. So a block of 10 integers will be allocated in memory, and A is a pointer. A will store the base address of these 10 elements, right? This will happen with the first line, and also one more thing will happen. All these elements will be initialized. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all these elements will be initialized. Then in the next line, what are we doing? Int star ptr. So we are creating a pointer explicitly. So we have created a pointer to an integer, and then it is storing the address of A3. Okay, not A. If it is equal to A, then it will store the base address of this array. But now it is not equal to A. It is storing the address of A3. So A123, this address. Okay. So it is 1006 if we assume that all the elements occupy 2 bytes. So pointer will contain 1006. So it is not pointing to the beginning, but to somewhere in between the array. Okay, so it is pointing to the 4th element of this array. So now we can imagine that PTR is a new array which is starting at location 1006. Okay, so there is no problem in this. And when we try to print the values PTR 0, what it will print? It will print 3. And when we try to print PTR 6, what it will print? It will print the last element, that is 9. Right? So let us run this example. Okay. So PTR can be assumed as a new array whose indices are starting at location 3 of the original array A. Okay. So when you try to print PTR 0, it will print 3, and when you try to print PTR 6, it will print the last element of the array A, that is 9. Right. Okay, here is another example. So what are we doing here? Here we are creating an array whose name is int array and whose size is 5. So compiler will allocate memory to 5 elements. All elements are of type integer and the values here are 31, 54, 77, 52 and 93. Okay, and int array actually is a pointer and it is pointing to the base address of this block of memory. So it is pointing to the first element of this block of memory. Okay, so this is happening with the first statement. And what are we doing in the next statement? We are going from j equal to 0 to j less than 5. It means we are iterating over all the elements of this array. 0, 1, 2, 3 and 4. And what are we doing at each iteration? We are doing star int array plus j. So what is this? This is, we have seen that this is same as writing int array j. Same thing. And when we try to interpret it, it means that it is int array, that is the base address stored in int array variable, plus j. Initially it is 0, so it will print the value at the 0th element, that is 31. Then when we increment j, it means now 1000 plus 1, means it will move to the next element. Okay, and actually not 1, it will add the size of one element. What is the size of one element? Size of one integer is suppose 2. So it will give us the value at the next element, that is 54. Then in the next iteration 1000 plus 2. It means it will jump from 1000 to 2 elements. So what is the size of 2 elements? Size of 2 elements is 4. It will jump to 1004 and give us the value there, that is 77. This is 1002, this is 1004, 1006 and 1008. So this is how this is working. You can try to implement this program and see yourself how this is working. Okay. And the next is pointer constants and pointer variables. Suppose that instead of adding j to int array, in the previous example, to step through the array addresses, you want to use the increment operator. Okay. So what is that you want? You want to write int array plus plus. So initially suppose int array is pointing to the first element. So int array is 1000. So you can say that when I write int array plus plus, it means int array is equal to int array plus 1, right? Can I do this? It will automatically go to the next element. So it will automatically go to 1000 plus next element. So it will jump 2 bytes and it will give me the address of the next element and I will print the value at that element. Can I do this? So what is the answer to this? Answer is no. What is the reason behind this? You cannot increment a constant. Constant? Where is a constant? As we discussed that int array, that is the name of the array, is a constant pointer. At the very beginning of this lecture, I told you that this is not a normal pointer, this is a constant pointer. Means to whichever block of memory it is pointing, throughout the program, it will point to that block of memory only. We cannot change this. Okay. But what are we doing here? We are changing it. We are making int array equal to int array plus 1. So we are making it equal to 1002. The previous value was 1000. So we are changing it. That is why this is not possible, because we cannot change a constant pointer. Okay. So the expression int array is the address where the system has chosen to place this array, and it will stay at this address until the program terminates. Why? Because int array is a pointer constant. Okay. And in the previous program, did we change int array? No, we did not change int array. Instead, we added int array plus j. Only j was changing. We were not changing it. That is why the program was working fine. But here what are we trying to do? We are trying to change int array. This is not allowed, right? But while you can't increment an address, you can increment a pointer that holds an address. So what we mean by this statement? Let us see in the next slide. So here is the answer to the solution to the previous problem. Here again we are creating the array of 5 elements: 31, 54, 77, 52 and 93, and this int array is the name of this array. In other words, this is a constant pointer which will hold the base address of this array. So this will not change. This will remain as it is throughout this program. Okay. Then what are we doing? This is a constant pointer. We are creating a normal pointer. Here we are creating another pointer whose name is ptr int. And this is a normal pointer. This is a constant pointer. This is a normal pointer. Okay. And ptr int is equal to int array. So whatever address is there in this array is also going here. So we are copying the address. So both of them are pointing to this block of memory. One is a constant pointer and another is a normal pointer. Okay. And now we cannot increment int array. We cannot do this int array plus plus. But we can do this ptr int plus plus. This is valid. So here we are printing each element using this for loop. Initially j is equal to 0 and j is varying from 0 to 1, 2, 3, 4. Okay. And what are we doing? Star ptr int plus plus. So initially ptr int is 1000. And star ptr int plus plus, what it will do? It will increment the value of pointer. Okay. So pointer will move to the next byte, next element. Okay. So it is equal to ptr int plus 1. So 1 means the next element. So how many bytes will be jumped? 2 bytes, because we are assuming that integer is occupying 2 bytes. So from 1000 it will change to 1002 and we will print the value at that address. And then in the next iteration again we are doing ptr plus plus, and then 1002 plus next element, it will go to 1004 and print the value at that address, and so on. So it will keep on doing like this. Okay. So now let us try to run this program. Okay. So we are printing 31, 54, 77, 52, 93. Okay. So we are able to print the values here. Moving forward, we have the topic how to pass an array to a function. Okay. So here is an example of passing an array to a function. What are we doing here? Let us go to the main function first. So in the main we have an integer variable average, and then we are having an array student. So what will be happening here? And a block of memory will be allocated, and this block of memory will contain 5 elements, and these 5 elements are initialized to values 67, 93, 88, 89 and 74, and student is actually a pointer variable, and this pointer variable will hold the base address of this block of memory. Okay, and then what are we doing here? Average equal to calculate. So what is calculate? Calculate is the name of the function. So we are calling this function calculate. And what are we passing here? We are passing student comma 5. So what is student? Student is a name of an array. What do you mean by name of an array? Name of array means we are passing a constant pointer. So we are doing pass by pointer here. We are passing the pointer. Okay. And then next we are passing the size of the array. So the control will shift from this statement to this function declarator. So here what are we doing? We are defining the function, and the function name is calculate. It will return an integer, and it has got 2 arguments. What is the first argument? The first argument means we are expecting an array. How can we say that? Because we have put these square brackets here. So square brackets means we are expecting an array. We are expecting an array. Okay, and expecting an array means we are expecting the address of the first element of the array, because the name of the array is actually an address. So we are passing the address here, and we will receive the address here. Okay, so int member means member is actually a pointer. Member is also actually a pointer, and it is a constant pointer, and it will hold the address of an integer. So we are passing the address of student. So student will be copied into member. So member is also pointing to this block of memory. This is how we pass an array. We pass the address of the first element of the array. Why? Because it is not possible to pass all the elements in an array. An array can contain hundreds or thousands of elements. So we cannot pass all these values by pass by value. It will result in a wastage of memory, because we have to copy all the values from the main function to the function to which we are calling. So instead of copying all the values, we just pass the reference, we just pass the address. Okay, so now after passing the address, how can we pass the address? By writing the name of the array. Why? Because the name of the array is the address of the array. Okay, and here we are receiving this address in the same fashion. Okay, we are writing int member and then square brackets. Here in the square brackets means we are expecting an array, and it means we are expecting address of a block of memory. Okay, expecting an array means we are expecting address of a block of memory. Okay, it also means that we are expecting a constant pointer. Okay, and that constant pointer will be stored inside this variable member. Okay, so member is also pointing to this block of memory. And instead of this notation, can we write int star member? Yes, we can do this thing also, because here we are explicitly creating a pointer. Okay, so this pointer member is also able to hold the address which we are passing. Okay, and here we are passing the size of the array. Here we do not need to mention the size. Okay, because the whenever we write the name of the array, it means the first base address. Okay, where the array is starting. We do not need to know how much bigger the size is. Okay, so we can leave these square brackets empty. Okay, so inside this function, what are we doing? We are creating an integer I. We are initializing an integer average equal to 0, and then this I variable is moving from 0 to less than size. So it is iterating over all the elements of this array. Okay, and then it is doing average equal to average plus member I. So it is adding all these values. Okay, 67 plus 93 plus 88 plus 89 plus 74. And when this loop ends, we are doing the average equal to average divided by 6. So the total will be divided by the size of the array, and then it is returning the answer. The answer will be printed in the next line, right? So let me erase the content on the slide. To indicate that to the compiler that a function is expecting an array, there must be square brackets following the array name in both the function prototype and the function definition, right? C++ automatically passes arrays by reference. As I already told you, we are passing the name of the array, means we are passing the address of the array. Dereferencing operator is not required because the name of the array is the address of the first element. So you do not need to put ampersand here. Okay, this is not required. The name of the array student is equal to ampersand student 0. So both of these things are same. Okay, so you do not need to put an ampersand before the name of the array.